Today we're in section 10.3 and 5, and that will cover both the surface area and the volume of pyramids. So pyramids, we know several things about a pyramid. All right, we see an image of the net here. The net is not necessarily, it's helpful because we can see that the base is kind of the core, and then all the lateral faces are formed off of that, and they fold up to form this peak, right? All the lateral faces come together to form a peak, and that's what makes it a pyramid. We classify a pyramid by its base. So in this case, I would call it a square pyramid. Another thing that we need to kind of set for the lesson, all right? So this whole lesson today, all of our pyramids are going to be regular. And what I mean by regular is that all sides and angles are equal. So that's going to be important, especially when we start doing triangular pyramids. You're going to see one side length, you're going to be like, what's the other side lengths? When it's regular, all the sides are equal. And I'll remind you of that in a minute too. All right, so the lateral faces are always triangles. If they weren't triangles, it wouldn't form a pyramid, okay? Because the top of a triangle is going to be a point. So all the lateral faces will be triangles, and the height is called the slant height. It's slant because, as you can see, the faces are coming in to form that peak. All right, slant height's the same thing as height. Okay, and then we have a formula, and I love it when I can kind of condense down and like use a letter to represent a phrase of words. In this case, there's not really a letter that represents a lateral face. So your book doesn't really use a formula with variables. It's just, we know we take the area of the base and we add the area of the lateral faces. Okay? So on a test, that's the formula that I would say is the one for pyramid. Okay? All right. So we've got our terms. Everybody good? Okay, so let's look at example 1. We have two different problems here. So that's why the dotted line is there, to show you that I have one problem and two. These are separate from each other. All right, everybody clear on that? So we're going to start in order. We're going to start on number 1. That's not what you see on the other side. Everybody see what I'm talking about there? Okay, so this is its own problem. It says, what is the surface area of a square pyramid with a base side length of 9 centimeters and a slant height of 7 centimeters? So I don't have an image to go off of. All right, so the description of the base is very important here. What kind, okay, and the base is labeled when it says what? Square. Okay, does everybody see how it says square pyramid? Yeah. There's a square pyramid, there's a rectangular pyramid, there's a triangular, and you can even go on to all the polygons. A hexagonal pyramid, right? A hexagon. Okay, now when they go above 4 sides, they usually tell you what the area of the base is. Okay, do you remember those problems where it gave you the base? You had a homework problem like that? So don't worry about, how do I calculate the area of a hex? Don't worry about that. But what I'm saying is the label of what kind of pyramid it is, especially when there's no image to look at, that's important. This is a square base, which means how many sides does it have? 4. Okay, that's important. We'll get to that in just a sec. All right, so here's our formula. And again, there's really no... I kind of wish that there was like variables, but we can kind of abbreviate. Remember what we're doing here. We're finding the area of the base of this figure, and we're adding the area of the lateral faces. Remember, those are the sides that form the peak of the pyramid. So the base, again, it tells me what the shape of the base is when it says square pyramid. I know that the base is a square that has a side length of 9 centimeters. So I'm going to use that. How do you find the area of a square? Does anybody remember the formula? Joel?
A equals 4 times I
No, that's perimeter. Okay, you could do length times width, but we know that all the sides are the same, right? So length times width would be 9 times 9, wouldn't it? Because all the sides are the same. So the formula for area of a square would be to square the side length. But that's the same thing as length times width. 9 times 9 or 9 squared is the same thing. Okay? So does everybody see why I did 9 squared to find the area of the base? Because my base is a square. Okay, so that's not multiplication, it's plus. All right, so then it's plus, let me change back to green, plus the area of the lateral faces. Well, what's the shape of the lateral faces of a pyramid? Always. They're always triangles. So I know I'm going to do the area of a triangle. 1/2 times the base. Well, the base of all my lateral faces, that's the side lengths of my base. Okay? And you can see that in this image too. Now, again, this image is a separate problem, but you can see how the side length of your base also forms the base of your lateral face. Okay? So the side length of my base in the first problem was 9, so the base of my lateral face is also 9.
Can you put 4 in parentheses when you're done with it? Because
Yes, you will. You will, but we're going to talk about that in a second. Times the slant height. All right, now we're ready to do some multiplication. 9 squared is 81. Okay, and then I'm going to take half. All right, I'm going to take half of, what's 9 times 7? 63. Okay, and I get 31.5. Does everybody see how I got 31.5? Yes. But I'm missing one thing. 31.5 is only the area of one of my lateral faces. Okay? And I don't have an image to go off of to see how many lateral faces I have.
4.
Except, why would you say 4? Because it's a square. You know that all your lateral faces start with those side lengths and extend up. So if it's a square, you will have 4 lateral faces. If it was a hexagonal base, how many lateral faces do you have? 6, because that's a hexagon. So however many sides are in the base, that's how many lateral faces you have. Okay, are y'all following along with the terms? Yeah. Base and lateral face. I know it sounds kind of fancy. Okay, so that's why I multiply 31.5 times 4. Because it had a square base, I know there are 4 lateral faces. Okay, and that's how I get my surface area. 207. Okay, so we're going to take a pause, and I want you to try the second one. All right, so on each of these examples, I put 2. So the first one I show you, the second one you do, and then you can compare your answers with each other. So we'll take a pause right here. All right, so again, we need to find the area of the base. So does everybody see why I did 5 squared? Yeah. Okay, so I can see here that this is a square pyramid again. So if I had said 5 times 5, is that the same thing?
Yes.
Yeah, okay. So either way, and then plus 1/2 times the base, which is still 5, times the height, which is 8. So 25 plus 20. But can someone raise your hand and tell me, why is my answer not 45? Hadley?
Because you need to multiply 20 times 4 because there's 4 sides to the triangle.
Very good. And that's not something I had to count either on the image, because I know that my base is a square. There will be 4 lateral faces. All right, so 20 times 4 gives me 105. All right, yay for square pyramids. Now let's talk about triangular pyramids. All right, now again, that description, what kind of pyramid, that tells me what the base is. Do you guys see that the base is now a triangle? Okay, so when you find the area of your base, you're using the area of a triangle formula to find the area of your base. Surface area. Okay, so that should be an S, sorry. Surface area equals 1/2 times the base length of, what's the length of the base of that triangle? 10. Okay, so again, this is the base of the pyramid that I'm trying to calculate, which is 10. And what is the height of my base?
14.
No. 8.7 is the height of the base triangle. Okay, what is 14? That's the slant height. Okay, so now I'm going to add the area of my lateral faces. So this gives me the base of the pyramid. Now I'm going to add 1/2 times the base of my lateral face, which is still 10. But now what's the height?
Wait, why is 8?
Okay, what's the height? I'll go back. What's the height of my lateral face now? 14. Okay, so are you guys confused on where I got 8.7? Okay, so look here, focus in on the base here. Do you see how this is the base of the pyramid? This 8.7 right here, it's pointing to the height of my base. Don't forget your formula. The height of your base. Okay, that's how you find the area of a triangle. You're trying to find the area of your base. Your base is a triangle. So 1/2 base times height here gives me the area of that triangular base. See that? If it was a rectangle, you do length times width. This is just how you find the area. Then you do the area of the lateral face, okay? But that still has a base of 10, but now it has a height of 14. Okay? All right, let's do the math. Okay? Go ahead and do the math to find your surface area. All right, so I got S equals 43.5 plus 70. Did y'all get that?
Yeah.
Okay, now think about what shape my base was in. Okay, because I can't add them together yet. What would I multiply by 70? 3. Because remember, the lateral faces go straight off the base. So if there's 3 sides in my base, that means there are 3 lateral faces. So now multiply that area times 3 to get your final surface area. Okay? All right, let's do the green one. I'm going to walk around and check on you guys and kind of see how you're doing on the triangles. Okay, guys, so area of my base. The base is a triangle. The base's length is 6. The base height is 5.2. Did everybody get that? The height of the base down here is 5.2, so that's what I plug in. Now I add that. I need to find the area of my lateral faces. So that's 6 again, 1/2 times 6. But now what's the height of my lateral face? 10. Okay? So I get 15.6 plus 30. But now what do I multiply 30 by? 3, because the base had 3 sides, which means there's 3 lateral faces, 1 of 5.6. Okay, questions? You see where you messed up if you made a mistake? Okay, so we're going to move on to volume. Okay, so volume, I do want you to pay close attention to this problem. I did not give you one like this on your homework, but you do have one on your quiz and your test. Okay, where that's clearly not a square, is it? That first one? No? Okay. But here's what it's going to do. Anything above a 4-sided base, it tells you the area of the base, which exactly, that should be your reaction. Yes, because I don't have to calculate the area. It tells me what it is. That's great, okay? So all you have to do, look at the formula. 1/3 times the base, big B, the area of the base, times the height of the figure. Now, I don't care how many lateral faces I have, because all I'm doing now with volume is filling the inside of it. So 1/3 times the area of the base times the height. Here we go. Again, it told me 48, so 1/3 times the area of the base, 48. I didn't have to do any math. I just plugged in that number. Times the height of the pyramid. Now, here's where I need you to do some kind of creative thinking. You need to take 1/3 of one of these numbers. You don't have the fraction button on your calculator. So to take 1/3 of something, you're dividing it by 3. Don't you think that might be kind of easy for 9, right? What's 1/3 of 9? 3. So now 3 times 48. Does everybody see where I got 3 and why the fraction is gone? Okay. Now the volume is 144.
Millimeters cubed.
Yep, millimeters cubed.
Is it gonna be that easy on everyone?
No, because it all depends on the base. So what kind of a base do we have on the purple figure?
Mr. Black and White.
On the second one.
Square. I mean a rectangle.
Is it a rectangle or a square?
Rectangle.
Yes. Why is it a rectangle? Yeah, because the sides, I heard it, the sides are not even. Okay, so I know it's a rectangle. Pretty simple to calculate area of a rectangle though, right?
Yeah.
Okay. Now, what's the base on the last one? It's a triangle. So you need to calculate the area of a triangle to find your base on that one. But we're getting ahead of ourselves. Okay, let's do the middle one next. Remember, to find the volume, we take 1/3 of the area of the base. Now, I'm going to put, if I need to do some math here, especially on the triangle, this is going to be important. If I need to do some math to find the area of the base, I want you to put it in brackets, all right? It just shows you that there's math being done to find B, to find the area of the base. I'm doing that math first, and then I'm going to multiply everything else. So that's why I'm going to put it in brackets, and that'll make more sense when we do the next problem. Okay? All right, so maybe try to get a step ahead of me on this. What would you do?
You do 2 different.
Not yet. Do 4 times 3. What's 4 times 3?
12.
So 1/3 of 12 times 7. 1/3 times 12 times 7. Now, would it be easy to do 1/3 of 7? Yeah, you're going to get a decimal, okay? Wouldn't it be easier to do 1/3 of 12?
Yes.
What's 1/3 of 12?
4.
And then 4 times 7 is 28. Okay, feet cubed. All right, do you see how I did that?
Different sides and not.
The numbers for the area of your base, I want you to put them in brackets. It would look something like this. V equals 1/3. Now start your brackets, because there's a lot of work you need to do to find the area of this base. The base is what shape?
Triangle.
It's a triangle. So that's where the 1/2 comes from. I'm finding the area of this triangular base. Okay? So what is the base length of that triangle?
7 and 8.
7. And then the height would be 18. Now you say, well, I looked at it and I thought the base was 18 and the height was 7. That's okay. That's okay if you did on the, again, you're just multiplying. Okay, so all of this calculates the area of your base. That's why we're putting it in brackets. We're saying we're doing this first. Then you multiply it by the height of the pyramid, which is 11. All right, so let's do this work inside the brackets. We're not worried about the 1/3 yet. What did you look to do first in here?
7 times 18.
I would do half of 18, right? You can do it at any order. What's half of 18?
9.
And then what's 9 times 7?
63.
Okay, so that's what I did. 1/3. Does everybody see how I got 63? Times 11. Okay. All right. Y'all want to do 1/3 of 11? No, that's gonna be repeating. Yeah, very good. 1/3 of. So could I evenly divide 63 by 3? So if it's 1/3, all I'm doing is taking that number and dividing it by 3. 63 divided by 3, 21 times 11. Okay, what's 21 times 11?
231.
All right, 231. Okay, you think you could do one of those? I think you have one on your homework, okay? Maybe 2. Don't quote me. I don't remember off the top of my head. All right, one more problem. We've got a roof. Roof is shaped like a square pyramid. One bundle of shingles covers 25 square feet. So how many bundles do you need? First question for you is this surface area or volume? Surface area, right?
Yes.
Because I'm not like putting the shingles inside, right? I'm covering the roof. So that's surface area. All right, so surface area involves the base. Do I need to find the area of my base?
No.
Would I be covering the base in shingles?
No.
No, right? So all I need is my what? My lateral faces, right? That's all I need. I don't need the area of my base here because I'm not covering it with shingles. This does remind me of the problem we did yesterday. Was it yesterday where we did the frosting the cake and we didn't have to frost the bottom? Okay, so we do have to think about this like reasonable. I don't have to put shingles on the bottom of this roof, so I don't need to know the base. All right, so surface area, I need to find the surface area of one of these lateral faces. All right, go ahead and try to do that. So again, I'm trying to figure out the coverage on this whole roof. 1/2 base times height. I got 135. Should I get 135?
Yeah.
Okay, but is that the whole roof?
No.
No. What would I multiply it by? 4, because it told me it was a square. Okay, so I know there's going to be 4 faces. Did you get 540?
Yes.
Okay, but now does this answer the question?
No.
How many bundles do you need?
22.
Addie, how'd you figure it out? Okay. Very good. So if I know how many square feet and I know one bundle covers 25, that gives me about 21.6. But what's going to happen if I go into Home Depot and I start ripping open a package to get my 0.6? I'm like, hey guys, I don't need a whole one. What are they going to say? No, you buy the whole one, right? You can't just buy part of one. And what's the problem with, aside from the fact that you rounded wrong, even if it was 21.2?
If you rounded down, you could have not much shingles.
Who wants to be up on a roof in the 100-degree Florida heat and be like 5 shingles short? And then you have to get down, you got to go back to the store. This goes for like any type of project that you're buying materials, you always buy a little more. You always want to account for waste, so at least 22 bundles. Honestly, if I'm standing there, I'm probably going to get 23 or 24, and I'd rather return 1 or 2 and be sure that I had enough. Isn't that the worst? Have you ever like painted something and you ran out of paint?
Yeah.
Or something along, you know. It's the worst, especially if you're painting, because then if it dries, it could like look different. So you always want to overestimate with materials. All right, that's everything for today's lesson.